finally tonight in the future of everything. I don't know about you, but I spent the weekend refreshing for updates on our favorite interstellar visitor, that comet or question mark 3I Atlas. It is up to a little bit more strangeness. Now, last week we told you that 3I Atlas...
Right now, something unusual is unfolding quietly in our solar system. No alarms, no dramatic announcements. Just a steady stream of data that refuses to behave the way scientists expect. An interstellar object known as 3I/Atlas is passing through our cosmic neighbourhood, and the deeper researchers look, the harder it becomes to explain what they're seeing. This is not speculation. This is observation, and what's emerging from the data suggests that 3I/Atlas may not fit neatly into any category we currently understand. If you follow real science as it happens, without hype, without exaggeration, make sure you subscribe because this story is still developing. Why 3I/Atlas is different from everything before? At first glance, 3I/Atlas appears unremarkable. A faint, fast-moving object on a hyperbolic trajectory, detected by automated sky surveys designed to spot near-Earth threats. But it didn't take long for astronomers to realise this wasn't just another comet or asteroid. Its velocity alone set it apart. 3I/Atlas is moving too fast to be gravitationally bound to the Sun. That makes it interstellar, only the third confirmed object of its kind ever observed. But being interstellar is just the beginning of the mystery. Unlike previous visitors, 3I/Atlas shows no obvious coma, no expanding cloud of gas, no classic tail streaming away from the Sun. Yet thermal readings indicate its surface temperature is high enough that volatile materials should be evaporating. They aren't. That contradiction forced scientists to look closer, and what they found only deepened the puzzle. The stability problem no one can explain. Natural objects tumble, especially ones that have travelled millions of years through interstellar space. Radiation pressure, uneven heating, micro-impacts, all of these forces introduce chaos. 3I/Atlas shows almost none. Its rotation is remarkably stable. Over weeks of observation, its spin rate has remained consistent within extremely tight margins. There is no measurable wobble, no chaotic tumbling, no gradual acceleration or deceleration from solar heating. In physics, this is a problem, because without active regulation or an unusually uniform internal structure, such stability should not persist. Even solid metal asteroids experience rotational drift. 3I/Atlas does not. This does not prove intent, but it does break expectations. The infrared pulses that started the questions. As the object approached closer to the inner solar system, infrared instruments detected something subtle but persistent. Faint thermal pulses appearing at regular intervals. Not bursts, not random fluctuations. Intervals. Natural outgassing tends to be chaotic, responsive to sunlight, rotation, and surface fractures. What scientists saw instead were emissions repeating on a predictable cycle. This immediately triggered internal review flags. Because patterns imply structure, NASA's automated systems flagged the emissions for secondary analysis. Independent observatories in Chile and Japan later reported similar periodic signatures, though weaker due to distance and atmospheric interference. Still, the timing matched. That alignment changed the conversation from instrument noise to anomaly. Why scientists are being extremely careful? At this point, it's important to understand what scientists are not saying. No one is calling 3I/Atlas a spacecraft. No one is claiming alien contact. No one is announcing discovery of intelligence. Instead, researchers are confronting something far more uncomfortable. The models don't work. Every explanation proposed so far, unusual ice composition, surface crusting, internal voids, solves one anomaly while making another worse. Stabilizing the rotation breaks thermal behavior models. Explaining the emissions breaks compositional assumptions. In science, this is a red flag, not of danger, but of incomplete understanding. Why not human technology? Became the key phrase. One phrase has quietly circulated among analysts reviewing the data. Not human technology. This does not mean artificial origin. It means that if the behavior were engineered, it does not resemble anything humans design. No known propulsion signatures. No waste heat patterns. No material behavior consistent with human alloys or construction logic. This matters because it removes one false shortcut. The question is no longer, is it technology? The question is, what process produces this behavior at all? That question remains unanswered. Why the data suddenly went quiet? As attention around 3I/Atlas intensified, something else changed: access. Publicly available data streams began updating less frequently. Raw telemetry that was previously shared among international teams started appearing only in processed summaries. This is not unprecedented, but the timing raised questions. At agencies like NASA, unusual findings often trigger internal review protocols. These reviews are designed to verify calibration, rule out instrument artifacts, and prevent premature conclusions. But they also slow transparency. Several researchers privately noted that approval for sharing raw data was taking longer than normal. No explanation was given, only the phrase "under interagency review." In science, silence doesn't imply secrecy, but it does imply uncertainty. Independent observatories step in. What prevented the discussion from stalling completely was independent confirmation. Observatories outside US control continued monitoring 3I/Atlas, using their own instruments. Teams in South America, East Asia, and Southern Europe reported faint but repeatable features that matched earlier findings. Stable rotation, weak but structured infrared variation. No visible coma despite solar proximity. Crucially, these observatories operate on different hardware, different software pipelines, and different calibration standards. When multiple systems see the same irregularities, coincidence becomes unlikely. This is where the story shifts from speculation to verification. The hydrogen line coincidence. One detail continues to draw quiet attention: a signal overlap near 1420 MHz, known as the hydrogen line. The hydrogen line is not mysterious. It's one of the most common natural frequencies in the universe. Neutral hydrogen emits it constantly. But what matters is how emissions appear. Natural hydrogen radiation is diffuse and noisy. What analysts noted here were brief, narrow spikes. Not strong, not loud, but structured. No one is calling it communication, but patterns at that frequency are never ignored. Even if the cause turns out to be exotic chemistry or plasma interactions, the implication is the same. 3I/Atlas is interacting with its environment in a way we have not documented before. Why the models keep failing? Every proposed explanation has a cost. If the object is solid metal rich, it shouldn't behave thermally this way. If it's icy, it should show outgassing. If it's porous, rotation should be unstable. If it's layered, emissions should vary with solar exposure. They don't. This does not mean the object is artificial. It means our assumptions about interstellar debris may be incomplete. Interstellar space is harsher, colder, and more irradiated than our solar system. Objects that survive there for billions of years may evolve in ways we've never observed locally. 3. I/Atlas may be the first example of that evolution. Why scientists refuse to rush the conclusion? There is enormous pressure, public, political, and academic, to label discoveries quickly. But this is exactly when scientists slow down. History is full of anomalies that vanished with better data. It's also full of discoveries that were missed because they were dismissed too quickly. Right now, researchers are doing the least dramatic thing possible. They're collecting more data. If the signals fade, the explanation may be natural and rare. If they intensify or sharpen, the models will have to change. Either outcome matters. What the next few weeks will decide. As 3I/Atlas approaches perihelion, conditions will change rapidly. Solar radiation will peak. Thermal stress will increase. If the object is volatile, it will reveal itself. If nothing changes, that's information too. Multiple coordinated observation windows are already scheduled. Radio, infrared, and optical instruments will watch simultaneously. That alignment removes ambiguity. Within weeks, one of two things will happen. The anomalies dissolve under scrutiny, or they solidify into something undeniable. There is no third option. What this moment really represents. This is not a story about aliens, it's a story about limits. For the first time, humanity is watching an object that formed around another star, using tools precise enough to notice when nature behaves outside expectation. That alone is historic. Whether 3I/Atlas turns out to be rare physics, exotic chemistry, or something we haven't named yet, it is already doing its job, forcing us to look harder, measure better, and question assumptions. Right now, 3 I/Atlas continues its silent passage through our solar system. No announcements, no answers yet, just data, and the patience to interpret it correctly. If you appreciate clear, evidence-based breakdowns of real space science as it unfolds, subscribe and stay with us. This story isn't finished, and whatever the outcome, it will change how we understand what moves between the stars. Stay curious and keep watching the sky.